the relationship between y equals f of x and y equals 1 divided by f of x. If you want to know what the graph of y equals 1 divided by f of x looks like, you can first sketch the graph of y equals f of x. Now we have an exercise here. Using the graph of y equals x minus 1 times x plus 2, sketch the graph of the rational function y equals 1 divided by that. Okay. I know, it's gotten to the point where I'm too lazy to even draw parabolas. But that's okay. So, we're going to use this parabola to draw the graph of y equals 1 divided by x minus 1 times x plus 2. And I think the first thing we can observe is that when this function on the bottom, this x minus 1 times x plus 2, when it equals 0, the whole thing is undefined. And in fact, as we get closer and closer to the points where it equals 0, here and here, the entire function is going to get bigger and bigger in terms of absolute value. So that means there's going to be vertical asymptotes for those points. So there's going to be a vertical asymptote at 2, x equals 2, and a vertical asymptote at x equals 1. So did I say 2? I meant negative 2. So vertical asymptote when x equals negative 2, and vertical asymptote when x equals 1. What else can we note? So something else we can note is that when the function, let's call this one f of x, and let's call this one r of x, when f of x is equal to 1, so is r of x. So whenever f of x takes the value 1, which it does here for this point and here for this point, that means that our function r of x is also going to go through those points. And then I think the parts on the left of the first vertical asymptote and the right of the second vertical asymptote are pretty easy to draw now, because all we need to do is observe that this function is going to keep getting bigger and bigger as x tends towards negative infinity. So therefore 1 divided by that is going to tend towards 0. And then of course, as we get closer and closer to x equals negative 2 from below, our function is going to, well, it's going to be 1 divided by a smaller and smaller but still positive number, and so that means the function is going to shoot upwards towards positive infinity. So let's go ahead and draw that. I'll use a different color. Okay, how wobbly that is. Nice. Alright, and then we still go through the points where f of x was equal to 1. And then we just tend towards 0 as x tends towards negative infinity. And the same kind of thing on the right hand side. Goodness me, it's almost getting to the point where I'd lose marks, I think, for this kind of wobbliness. Try and be better. Alright, now all that's left to deal with is this this part in the middle of the two vertical asymptotes here. And we can see that the minimum point is this one right here. And that's when x is equal to negative 0.5. And if you want, you can put x equals negative 0.5 into this function to show that when x is equal to negative 0.5, y is equal to negative 2.25. So minimum at the point negative 0.5, negative 2.25. And so clearly for this negative part down here, it's also going to be the maximum for our function r of x when x is equal to negative 0.5, because all the other r of x values in this interval here between negative 2 and 1 are going to be bigger in terms of modulus, but they're still going to be negative. Okay, and 1 divided by negative 2.25 is exactly negative 4/9, so that's going to be approximately about here, just under negative 0.5. So we know our function is going to go through that point, and we also know that when our function is equal, or when our function f of x is equal to negative 1, so is the function r of x, because 1 divided by negative 1 is still negative 1. So we also know that the function r of x is going to go through this point and this point. And then from here, I think it's pretty clear what happens, because as the function f of x goes towards 0, but from the negative side, that means that our function r of x, which is 1 over f of x, is going to tend towards negative infinity. So that means it's going to look like this. It's going to tend towards those vertical asymptotes. And we're done. So the purple function is y equals 1 divided by x minus 1 times x plus 2. So here are some notes in general for finding the graph of y equals 1 divided by f of x given the graph of y equals f of x. The first one is that the zeros of y equal f of x become the vertical asymptotes of y equals 1 divided by f of x. And we already saw that before. Meanwhile, the vertical asymptotes of y equals f of x become the zeros of y equals 1 divided by f of x, because as f of x is tending towards infinity or negative infinity, that means that 1 divided by f of x is tending towards 0. Except in the graph of y equals 1 divided by f of x, there are holes at these points. And the question is why? And that's because 1 divided by f of x is not defined at those x values, at the x values with vertical asymptotes. Because f of x is not defined there, so that means that 1 divided by f of x can't be defined there. Where y tends towards 0 from above in y equals f of x, we have y tends towards infinity in y equals 1 divided by f of x. Now, obviously what I mean by from above, it means the output values of f of x are positive, but they're getting closer and closer to 0, but they're still positive. So then 1 divided by f of x tends towards positive infinity. Meanwhile, where y tends towards 0 from below, so negative in y equals f of x, then y tends towards negative infinity, because 1 over f of x is still growing bigger in modulus, but all the values are negative. So y equals 1 divided by f of x is tending towards negative infinity. And we already saw an example of this, and it's the same kind of thing as with the vertical asymptotes part up here. When y tends towards infinity, so positive infinity in y equals f of x, that means that y tends towards 0 from above in y equals 1 divided by f of x. Where y tends towards negative infinity in y equals f of x, y tends towards 0 from below in y equals 1 divided by f of x. And just a few more notes about it. If f of x is a function, then 1 divided by f of x is called the reciprocal function. if y equals f of x is greater than 1, then that means that 0 is less than y equals 1 divided by f of x, which is less than 1. If 0 is less than y equals f of x, which is less than 1, then that means that y equals 1 divided by f of x is bigger than 1. So these are just properties of numbers. And also, if y is equal to f of x is less than negative 1, then that means that negative 1 is less than y equals 1 divided by f of x, which is less than 0. And if negative 1 is less than y equals f of x is less than 0, then that means that y equals 1 divided by f of x is less than negative 1. So those are all kind of common sense things that you can figure out, but they're useful for sketching the graph of y equals 1 divided by f of x, given the graph of y equals f of x. And then lastly, which is also a very nice important one, the points on the lines y equals 1 and y equals negative 1 do not move. In other words, if y equals f of x is equal to 1 or negative 1 at that point, then so is y equals 1 divided by f of x.